We are asked to use vertical line test to determine which of the graph in this picture are function. So we have a three different graph, okay, and every graph they are not a function, okay. And in order to test whether the given graph is a function or not, we use a vertical line test, okay. So using vertical line test means we draw vertical line, okay. You can draw vertical line anywhere on the graph, and if every vertical line on the graph crosses the graph exactly at one point, okay. So let me draw vertical line here, okay. Let me draw here. So wherever you draw vertical line on this graph, those vertical line crosses the graph exactly at one point, right? And if this is the case, our graph is a function, okay. We draw a vertical line, and if every vertical line on the graph crosses the graph exactly at one point, then those graphs are a function. Now in graph B, so if we draw a vertical line on graph B, so you can draw graph B vertical line here, okay. Now here the vertical line crosses the graph more than one point, see. So the vertical line crosses at 2 point. In this case vertical line crosses at 4 point. In this case the vertical line crosses at 3 point. And if this is the case, our graph is not a function, okay. So to be a function, every vertical line must cross the graph exactly at one point. If it crosses more than once, then the graph is not a function. Now what about our graph C? Is it a function or not? It's a function, right? So no matter where you draw a vertical line always crosses the graph at exactly at one point, okay. And this makes our graph a function. So first graph, this is a function, okay. Second graph, not a function, and third graph, it is a function, okay. So we use vertical line to test whether given graph is a function or not, and if any vertical line crosses the graph more than once, then those graphs are not a function, okay. Any question? Now the next here, which of the following equation describe y as a function of x? Now let's write down this equation in terms of y. So we subtract 2x on both sides. So we have negative y equals to negative 2x plus 1. Let's divide each term by negative 1. And we have our y equals to positive 2x negative 1. Now we have this equation, okay, and this is same as this equation, and we want to know whether this equation describe a function of x or not. Now to be a function, what we need, for every value of x we need to have exactly one value of y, okay. Now can you think of a okay, so for every value of x we need exactly one value of y. Now for any value of x, is it possible to have two different value of y? So if you choose any real number, this is a linear, okay. If we choose any real number for x, for one value of x, is it possible to get two different value of y? No, right? And because of that, this equation describes a function, okay. So this is a function. So if every value of x has exactly one value of y, then that is a function. So for every value of x, we get exactly one value of y. Now next here we have absolute value of y equals to x. Now same. Now for Okay. So here, to be a function for every value of x, we need to have exactly one value of y. Now, what about this one? Is this a function or not? No. Y is not a function.
If we were to do put x as 3 or -3, y would be 3 either way.
So if our y is, okay, so if we pick our y equals to +3 or -3, so if our y is -3, y is +3, what is our x? X is always equals to +3, right? Absolute value of -3 is 3, absolute value of +3 is 3. Now for one value of x, we have a two different value of y. But to be a function, every value of x must have exactly one value of y. But when our x is 3, it has two different value of y. And because of this equation do not describe a function, not a function. Okay? So every value of x must give exactly one value of y. If that is the case, then equation is a function. Okay, so if one value of x gives more than one value of y, then that is not a function. Any question up to here? Okay, now let's go to the next one. So here we have a graph and we are asked to find x-intercept, y-intercept, domain and range. Now, yes. Oh, you can choose any number. It doesn't matter, okay? I just pick a 3. So if you want to pick 4, our y would be -4 and +4. And still this is not a function, okay? Any question?
I'm so confused by it. Like, I know it's like not a function but I'm still like trying to figure out.
Okay, now let me use a mapping diagram, okay? So let's say we have a set here, our set x, we have a set y, okay? So let me pick y equals to, okay, let me pick different number. Let's say our y is -1. If our y is -1 in this equation, what will be the value of x? You substitute y equals to -1 and absolute value of -1 is +1, right? So we get x equals to +1. Now let me take y equals to +1. So if our y is +1, what is the absolute value of +1? It is 1, and which is our x. Now let me take y equals to -2. Absolute value of -2 is +2. So let me take +2. Absolute value of +2 is hold on. So absolute value of -2 has to be +2, right? So here, if our y is -2, then absolute value of -2 has to be +2. This is not negative. And absolute value of +2 is also +2. Now here, our x has 1. So since we do not repeat, so let me get rid of this one, okay. Now here, in this mapping diagram, one value of x has more than one value of y, okay. To be a function, what we need, every value of x must have exactly one value. But from this equation, our 1, when our x is 1, we get two values of y, okay. So in this equation, when our x is 1, we get two values of y. When our x is 2, we get two values of y. And because of this, our second equation is not a function. Yes. Oh, you can pick any number, okay. So it's not that you always need to pick 2 here. So you can pick any real number, okay. So if you take your y to be +10, what will get for our x? Absolute value of 10 is we get 10. And if you pick y equals to negative 10, absolute value of negative 10 is equals to 10. Okay, for two different value of y, we have same value of x, and because of this equation is not a function.
So if it has absolute value,
If it has absolute value, then what?
it's just not a function.
Not in this case. Now, if we go back to our previous, okay, now let me go back here. We had a graph. Okay. So here. Okay. Now here. So this is also our absolute value function, right? So we have f of x equals to absolute value of x. But this is a function. And how do we know this graph is a function? We use a vertical line test. If we draw a vertical line anywhere, it crosses at one point. Okay. So using vertical line test, we can tell this graph is our function. Okay. So it's not that absolute value is not always a function, but this equation, absolute value of y equals to x, is not a function. Okay. Or you can just graph this, and once you graph, use the vertical line test. Okay, draw a vertical line, and if every vertical line crosses more than once, then it is not a function. Okay, in this example, we are asked to find x-intercept, y-intercept, domain, and range. Okay, what is x-intercept for this case, for this graph? X-intercept mean it is the point where a graph crosses at x-axis. Now, can you tell me a point where this graph crosses at or touches x-axis? 0, 0. So 0, 0 is x-intercept. So we have next y-intercept. Now, what about y-intercept? It is a point where graph crosses or touches y-axis. Now, what is that point? 0, 0, right? So 0, 0 is y-intercept. Now next, let's find the domain. Finding domain mean how far you can extend this graph on the right, left, or what are the values of x this graph has. Okay. Now we have a two graph here. Okay. So this is a piecewise function. Now let's write a domain for this part. Now, so when you are writing interval, you are always starting from left to right. Okay. So you can take this point as a starting point, or you can extend this graph all the way to the negative infinity. So let's take this as a starting point. Okay, for this graph. So this graph is starting from what value of x? It is starting from -2, and how far it's going? So it's ending at 0, right? At x equals to 0. So from -2 to 0. Okay, so this is the domain for the left part of a graph. Okay, now 0 is included. Okay, we have a closed circle. It means we have a bracket here because 0 is included here. So we see a closed circle here. Okay. Now let's write down a domain for this part of a graph. Now, what is the starting point for that graph? It's 2, right? Now is this 2 included in this graph? And how do we know that? From this open circle. Open circle means 2 is not included. So we have a parenthesis at 2. And how far it is extended? Now here, you can just write down 5, or if you put arrow here, we can say up to infinity. Okay, so from -2 to 0, or, okay, this is or, union 2 to positive infinity is the domain for this graph. Or if you just put arrow here, you will have from negative infinity to 0. Okay.
So that's negative infinity.
Yeah, so look it. So if you have like arrow here, you can replace -2 by negative infinity. Still is correct. Okay. But if you want to start from -2, it still is correct. Okay. Now the next we have our range, and range is we are looking along the y-axis. Okay. Now what are the possible y values that this graph can have? Now our graph, so we are looking along the y-axis. Okay. Now do we have a graph below our 0 here? Do we have any graph here? Now if you extend on a both side, we do not get a graph below x-axis, right? It means every negative numbers are not the range, but this graph can have a y value. Okay, so what is the smallest y value this graph can have? 0, right? Because the graph touches y-axis here, and if you extend your graph, then it can have all the way up to positive infinity. So from 0 to positive infinity, 0 is included because we have a closed circle, parenthesis with infinity. So from 0 to infinity is the range for this graph. So you are writing every y values for that graph if you are asked to write down the range, and to write down the domain, you are looking along the x-axis. And when you write an interval, small number has to be always on the left. Okay, big number has to be always on the right. Okay. Now next here we have the next graph. Let's write down the x-intercept. Now what are the point where the graph touches or crosses x-axis here? So what are the x-intercept? So this point is x-intercept, right? And this point is x-intercept. So we have -1, 0, 2, 0. So these two are the x-intercept. So it's the point where the graph touches or crosses x-axis. Next we have a y-intercept, and y-intercept is the point where graph touches or crosses y-axis, and the graph crosses y-axis at this point. Is it 4.5, -4.5 or -4? What do you think? You want to take -4? It's fine. Okay, if you want to take -4, so 0, -4. So this is the y-intercept. Now let's write down the domain and range. Let me add arrow on the left end and arrow on the right end. Now, what is the domain for this graph? Now, can you extend your graph all the way to the left and all the way to the right? It means all real number is a domain. So from -infinity to positive infinity. Next, range. Now, when you extend, does your graph go all the way down or all the way up along y-axis? It means every real number is a domain. Sorry, range. So from -infinity to positive infinity. Okay, so if you can extend on a both side, it's always all real number. If your graph can be extended all the way along y-axis, then it is all real number is a range. Okay, any question up to here? Okay, the last question for this section here we have the volume of a sphere of a radius r is given by this function. So we have a function v of r. So v of r is a function, and this function is 4/3 pi times r cube. Now here, what is our v? V is the volume function. Okay, it's a name of a function. And what is our input here? What do we have as an input for this function? R. Okay, so R is a input. And what represents the output? V of R. Okay, so volume is the output. Radius is the input. So you input the radius. It means you substitute the value of R and you get the volume. Okay, so our radius is input, volume is output. Now here it's asking us to sketch a graph for this function for r greater than 0. Now why we need r to be greater than 0? Why can't we have r equals to 0 or less than 0? Now we are talking about the radius, right? Our r is a radius. can r be 0? Can r be negative number? R is radius is a distance, right? So it's not, distance cannot be 0. It's never negative. Okay, because of that, our input has to be always greater than 0. Okay, so the domain for this function, okay, domain for this function is from 0 to positive infinity, excluding 0. Now let's graph this function. To graph, we need the input. Our input is r, output is vr. Input output together it gives a point. Okay, so let's pick r. So what r do you want to pick? But make sure your r has to be greater than 0. Now let's pick r equals to 1. See, if r is equals to 1, what will be the volume of the sphere with radius 1? You substitute r equals to 1. So we have 4 by 3 pi. Now, okay, I need help here. Has anyone carried calculator? So what is 4 over 3 times pi? Can you help me? So just replace your r by 1. So 4 over 3 times pi. What is pi? 22 over 7 times 1 cube. Can you do 4 over 3 times 22 over 7 times 1 cube?
4.186.
4.186. So let me take 4 point.
4.186 repeating.
Okay, so let me just round and just write 4.2. Okay, let's take our r equals to 2. So if our radius is 2, then what will be our volume? So 4.2 is 1 point. Okay. What will be the volume when radius is 2? The volume has to be greater than 4.2 for sure. 4 over 3 times 22 over 7 into 2 cube.
33.5, you're rounding up.
33.5.
5.
Okay. So we have 33.5. Now let's take r equals to 3. What will be the volume? You replace r by 3.
113.04.
04. Okay, this 113. Let's take. So that's 3. 113. So let's take 4. Then we should be good. So when our r is 4, what do we get as a volume?
Or 268 rounded up.
Okay, 268. 268. So we have 268. So let's try to graph this. Okay, so we need the vertical axis, we need the horizontal axis. What do we call horizontal axis in our case? What is our horizontal axis in this case? It's not x-axis. What do we call here? R. Okay, input. Always input has to be your horizontal axis, and the output v of r has to be vertical axis. Okay. Okay, so our r is 1 2 3 4 5 6. Okay, it's a big number. Let's see. Let's say this is 10 20 30 40 and so on. So 4.2 somewhere here. 233.5. Okay, 2033 somewhere here. Yeah, looks like we may not get a perfect graph here. 313. So 3 somewhere here. Let's say. Okay. 268. This is 268, maybe somewhere here, let's say. Okay, now let's connect this graph. we do not get a straight line, okay, because this is not a linear, right? That's what we know. So let me try to make this not a linear, okay. We don't want a straight line here because that's not what we'll get. So we will not get a straight line, okay. Now how far can we extend this graph on the left? How far? Now can we have our r less than 1? Can we have 0.5 as a radius? Is a 0.5 a positive number? Yes, right? We can have a 0.5 as a radius. So we can extend this graph all the way up to 0, but when you are at 0, we must have an open circle. Okay, because 0 is not included. Okay, so that is an open circle. Okay, but we can have any number greater than 0. So this is a graph for this volume function. Any question up to here?